So I'm going to randomly run through a couple of questions, and from the couple of questions, hopefully you can complete all the questions here. So all the questions here will support the theory that I have mentioned. So the very first one, there are 4 parts to question 1. I will not be showing you all the 4 parts. So in this question, what does the discriminant tells you about the nature of roots? So the question is, what does the discriminant tells you? So I'm not going to calculate the roots. I'm still going to get my ABC. I'm going to calculate the value of the discriminant. I'm not going to work out the roots. So in this case, after I calculate the discriminant, you realize that you are getting a positive value for the discriminant. So if you go back to the example, since the discriminant is positive, then the equation has real and distinct roots. So I'm not going to calculate the value of the roots because I'm not concerned about the value of the roots. I'm concerned about how many roots will I have. So in this case, it's positive. So I'm quite sure that I'll be getting 2 roots. The proper words to describe 2 roots will be called real and distinct. So that's question 1. So you can explore the rest of question 1. If you still cannot remember the nature, you can always refer to the example. Okay, so subsequently, if you look at question 2, you realize that they are asking you to calculate a certain value for P. And this value of P can be found from the equation if I know that the equation has real roots. Okay, so let's explore the equation first. So usually when I explore a quadratic equation, I would like to know what are the values of A, B, C. So in this case, I'm going to rearrange. I'm going to rearrange. I'm going to do a comparison with the general format of the equation. So when I do the general format of the equation, I can see clearly what is my ABC. So do you realize that, okay, so far the ABC that you have encountered are values. That means you can see the numbers. So here, the ABC that we have some unknown. So how are you going to find the unknown? So do you realize that the question is asking you to find the unknown? So, okay, what is the idea of equal roots? Okay, so that's another. Now we got to apply the theory. So since the equation has equal roots, so go back to the example. So which is the idea of equal roots? Equal roots is as good as the category of real and equal. So where the 2 roots actually becomes equal. So what are the conditions for the discriminant? So the condition for the discriminant is equal to 0. So now we're going to work backwards. Right now they are telling me that, so this one is equal roots. So being equal roots will have the idea that the discriminant is equal to 0. So I'm going to explore the discriminant. So I'm going to explore the discriminant. So I'm going to explore the discriminant. So do you realize that the discriminant is not a value, it's an expression? So, and my discriminant is going to be equal to 0. So therefore, the whole expression will be equal to 0. So you end up as a quadratic equation in P. So you do as you usually do. How are you going to solve a quadratic equation? Okay, so can you still use your quadratic formula? Yes, you can still use the quadratic formula. So I'm going to use the quadratic formula to solve for P. Okay, why can I do that? Because this is a quadratic equation. So right now, the equation is in P, the quadratic is in P. If I use the formula, it will help me to solve for P. So the solving is the same. So you realize that the solving will be the same. So in this case, right, I still have 2 answers. So I managed to find 2 answers for P, knowing that the equation has equal roots. Because knowing that the equation has equal roots means that the discriminant is equal to 0. So that is the idea. So we use the concept of nature of roots to help us to answer the question of finding some unknown. So in this question, our unknown is P. Our unknown is not X. X is the roots. Okay, so this is one of the kind of question. Okay, so maybe we can explore other. So I will show you one more question, and after this, you see whether you can deduce it to other stuff or not. So for question 3, I got the equation, and the equation has no roots. So we are supposed to find the range of H. Okay, so again, I'm going to explore the equation. So every time we explore the quadratic equation, you must be able to tell your ABC. See, compared to the general format. So compare to the general format, and you see whether you can tell your A, your B, and your C. So after I explore the equation, so the equation has no roots, has no real roots. So what is the indication about no real roots? Okay, why will you end up no answers for X? So your discriminant is actually negative. Because of negative discriminant, you couldn't take a square root, so you can't get any answer for X. No roots means no answers for X. Okay, so in that case, I'm going to explore my discriminant. So my discriminant will be minus 9 squared minus 4AC. So that will be this. So I'm going to apply the condition. So my discriminant is expected to be negative. So that is like your linear inequality. So all of you have learned some form of linear inequality. So do you still remember your linear inequality? Do you still remember that you actually got to reverse the sign when you divide by a negative number? So that's why the question is, what is the range of H? That means as long as H is bigger than 5 and 1 over 16, the equation will end up having no roots. So that's why there will be some amount of inequality for this section. So this one currently is still what we'll call linear inequality. Okay, coming up, you'll be learning something else called quadratic inequality. That is another section. So for this section, you just be clear about exploring equation in terms of ABC and exploring the condition of the discriminant. If you know the number of roots, if you know the nature of roots. Okay, so the phrasing is actually very, very different from the EMAF part. EMAF, we are concerned about the calculation. Here, I'm totally not concerned at all.